Hello. Um, and this will be an IBU linear function. So in this video, I will do I will do four introductory tests regarding linear functions regarding the IBU exam. So let's begin. So yeah, let's start with recognizing graphs of linear functions. So when I took the practice test, there is a lot of linear functions. Um, So it's good to know how to determine if it's a linear function and how to graph it, right? So let's look at question one. Which of the following represents a linear relationship? So what is a linear relationship or a linear function? So believe it or not, there's several ways you can call a linear function. A function can look positive, and yeah, it could look positive like this. And see how it's going completely straight, like a straight line? It can also go completely negative, like this. And believe it or not, it can actually go vertical or horizontal like this. Okay. So those are all linear functions. So yeah. So what we have to do is figure out which one is a linear function. Um, let's look at the first question. Does that look like a linear function? So if I connect the dots, I think it is a linear function. It's just positive. See? What about, let's look at the other ones. This one looks like a linear function. Um, so it could be that one as well. What about this one? No, that does not look like a function. It looks more like a parabola because if you connect the dots, it kind of makes like a U shape. So I don't think it's that one. I don't think it's this one either because one more thing about a linear function, they have a slope. They have a in a linear function, you have something what's a constant. You have what's called a slope, which is basically the change of y over change of x, or basically rise over run. And it has to be constant. So um if your rise is 2 and your run is 3, it has to repeat that pattern. Um yeah, this does not repeat a pattern and it's kind of yeah, see how this dot isn't aligned with it. It should be somewhere around here, so it can't be that one. So it's either the first two. So let's look at the first one again. I mean, could we figure out the rise and the run? So this one has a rise maybe like one half and then a run of one. One half run of one. That looks good. What about the other one? Hmm. Also, in a linear function, I believe you can't have the same x repeat. So what I mean is if you plot this point right here, this is -4, this dot right here is -4, comma, -3, right? This dot right here is at -3, comma, mm, it's some kind of number, I'm not sure, but as long as the x value doesn't repeat, you're good. This one, -1, it looks like it's Man, they look both good. What could be a linear function? It's either the first one, second one, definitely not the third one, definitely not the fourth one. What could it be? Yeah, I think this doesn't come out nicely. This is if you connect the dots, it doesn't really make a straight like if you yeah, it doesn't make a really straight line. This one makes a very straight line. Let me double check. So try to just connect the dots. If it's slightly curved, it's not going to be it. So this looks good. Let's see if it works. Uh, Yeah, correct answer is A. Oh, and B. Okay. I didn't even know you can have more than one correct answer. So on this one, A and B are correct. So the first one and the second one. So they both look good. Okay. So you just have to know it's either or like a slant like going positive or negative, and yeah, it doesn't like this one has a little curve. It's not going to be a straight line anymore. This one, this curve just a little, if you connect the dots, it's not going to form a line. Okay, good. That was a tricky one. Question two, which of the following represents a linear function? Wait, did I do this one? No. Let's see. I don't think this one works because it kind of curves. It looks like exponential. So yeah, that kind of curves just a bit. This one looks good. If you connect the dots, it doesn't matter how, uh, let's see, how many rise? So one, two, three, left one. What, your you rise, so it's going to be minus, your slope is going to be, you rise one, two, three, and then run one. So one, two, three, one, one, two, three, one. This is good. The slope has to be constant. It has to constantly rise three and then run one to the left. So maybe this one is. This one, no. This is a curve. It curves down, concave down. It's a parabola. This one, oh, didn't we say linear lines are also horizontal? Yes, we did. So this could be a linear line. So maybe this is one of those where you pick two. So this one and this one. This one curves, so it can't be. Let's see our answers. B and D, is that what we chose? Yes, B and the last one. So like we said, a linear line can be completely horizontal. So it can be a completely horizontal line like this. And believe it or not, it can also be completely vertical like this. And it can go positive, it can also go negative. It cannot curve in any way. So if there's a little bit of curve, it's no longer a linear line. Okay, which of the following represents a linear relationship? This one is fine. This is a horizontal line at y equals 0. See how this is a completely horizontal line? We said the horizontal and vertical lines are linear. So definitely yes to the first one. This one, no. This is more like this is like a log graph. No, this is not linear. See how it curves right here? No. This one is absolutely no. It's a parabola. It's a U-shaped parabola. Yeah, that's not linear. This one looks good, right? This one it goes through the origin. It's a straight line going to the positive direction. So this one looks good and the horizontal line. But this one, that one no. That one no. And then the last one, yes. Correct. So first one and the last one. Okay. Question four, is this a linear line? Yes. It goes through the origin. Definitely pop. Yes. It's just in the negative direction. We said that's fine. This one, no, there's a little bit of a curve. So no, that's not a linear line. This one looks good. It's just a linear line that's going negative. We said that's perfectly fine. This one has a little V. This is an absolute value graph. So no, there's a little V. Yeah, there's a little cusp right here between the two and -1. That is a uh absolute value graph. Okay, so we agree that it's the first one, not the second one, and then this one, and then not that one. Correct answer is A and C. Good. Okay, what about this one? Do you think this is a linear line? I don't think so. See how it curved? That you see that this is not a straight or this is not a straight line. This curves a little slightly a bit. So it's not that one. This one looks good. It's see how it's going on the negative direction and it's a completely straight line. That looks good. This one, there's a cusp or there's a V shape. It's a absolute value graph, so definitely not that one. This one looks good. Wait, yeah, it looks like a straight line. It's just going negative. I think that looks good. So we said it was not the first one. Second one, yes. Third, this one, no. This one, yes. Good. B and D. Okay, what about this one? Which of the following represents a linear relationship? This one is okay. It's a ho completely horizontal line, so yes. This one, there's a little bit of a curve, so no. This one, okay. That looks good. It's just it's in the pot. It's just really a higher slope, but it's still a straight line going in the positive direction. So yes, this one it looks like some kind of sine graph or a wave graph, sine graph or a cosine graph. That's not linear. The correct answer is A and C. Good. Yep. Perfect. Yeah, I think we miss. What did I miss? The first one, right? Okay. Okay. So now let's talk about slope. So what is slope of a linear line? So there's a lot of ways. So there's a lot of ways you can determine it, how to find the slope. So yes. So wait, let me re-explain. So this is a typical form of a linear line, y equals mx plus b. There are other forms. There is standard form, right? There's point slope form, but usually we start with this form. And then this, if you have it in this form, you can easily find the slope. And the slope is uh could be expressed as the m is the rise over run. Yeah, rise over run, and then there's also, or you could call it the change of y over change of x, right? There's also another way. If they give you coordinates, you could, if you are given two coordinates, you can find the slope by using the slope formula, which is y2 over y1 over x2 minus x1. What does that mean? Okay, so I think we're going to use this formula. So what we'll have to do is you can, yes, so if you look at one, this is just technically a linear line. What we got to do is figure out what is the slope. So I do forget, it's either a horizontal line or a vertical line that's either zero or undefined. So if you forget, what you do is pick 2 points on this graph, so it doesn't matter. So in a point, if you recall, a point in a Cartesian plane is an x comma y. So if I pick this point right here, this would be expressed as 1 comma 2. Okay. And then if I pick another random point that's exactly on the line, say I pick this point, that would be expressed as 2 comma 3. Okay. So we picked 2 points already. So all we got to do is use this formula. So what is my y2, y1, x2, x1? So this is why we label this carefully. So this, I'm going to label this x1, y1, x2, y2, right? So my slope, if you put in this is why I label it so you don't get confused. My y2 is going to be 3 minus my y1, which is 2. And then my x2 is 2 minus my x1 is 1. So 3 minus 2 is 1, and then 2 minus 1 is 1. Wait, is it that right? I gotta double check. 1 comma 2. I thought it would be either 0 or undefined. This is 1 comma 2, and then this is 2 comma. Oh, my mistake. This is not 2 comma 3. This is 2 comma 2. Okay. So that changes everything a bit. Okay, so it's y2, which is 3, minus y1, which is 2. My x2 is 2, minus my x1 is 1. So 3 minus 2 is 1, and then 2 minus 1 is 1. So yeah, our slope is 1. Wait, 1 comma 2, 2, 2 comma 2. Ah, I messed up again. Why did I put a 3? Where's my mind? Yeah, it looks like, so okay. This is 2 comma 2 this point, and then it's just going to be y2, which is 2, minus my y1, which is 2. My x2 is 2, minus my x1 is 1. So 2 minus 2 is 0. There we go. 2 minus 1 is 0. So it's 0. So if it's 0, if the 0 is on the top, it's fine. Anything number like 0 over 5, it's always going to be 0. But if it was 0 on the bottom, that is undefined. So if it was like 5 over 0 or 1 over 0, that's undefined, right? So 0. So now you know that all horizontal lines, like this one's, it doesn't matter if it's like here or on the negative. If it's a completely horizontal line, you know that the slope will always be 0. So keep it note and keep that in note. All horizontal lines, horizontal, well, they're actually linear as well. Horizontal linear lines has a slope of 0. Okay, good. So this one, we said it's 0, which is technically, oh, 0. Correct. Good. Correct to see. So yeah, just note all horizontal lines will always have a slope of zero because we just did the algebra. Okay, this one, this is a linear line and it's going on the negative, so I have a big idea that our slope will definitely be some kind of negative value. So what you could do is try to like, I can't really tell, like I can't really, so what I would do is like, it goes through the origin and figure out how much it rises and how much it runs. I'm not really sure with that method, so what I'm going to do just to be sure, to be safe, pick two random points that are exactly on the line. So I see it goes through the origin, so you can definitely use that point zero zero. And then I need an exact point on this line. So maybe this one right here. And then that is expressed as negative 1 comma 5, right? X direction, then Y direction. Okay, so this is going to be, then I'm going to label this X1, Y1, X2, Y2. So slope formula, the slope when you're given two coordinates is Y2 minus Y1 over x2 minus x1. So this is why I labeled this so I don't get confused. So my y2 is 5 minus my y1 is 0. My x2 is negative 1 minus my x1, which is 0. So 5 minus 0 is 5. Negative 1 minus 0 is negative 1. So it looks like our slope is negative 5 or negative 5 over 1. So that kind of makes sense. So if you look at the origin, start here. Remember, slope is also rise over run. So you rise 5, so you go up 5, 1, 2, 3, 4, 5, and then we run 1 to the left because it's going negative. So yeah, that does make sense. So it's our slope is definitely negative 5. Oh, they don't say the numbers, but we said it was negative because it's going to the left. Okay, so yeah, just remember, note, if your graph is going to the left, it's negative. If it's going to the right, your slope is positive. Okay, let's look at this graph. This graph, this is graph is definitely negative because it's going to the left. Um, this time they actually want an actual value, so you can eliminate the first two because that's positive. Our slope is negative because it's heading to the left. So you could do the last two. It's either negative or one, negative one third. So what you do is you're going to pick two random points that are exactly on the graph. So I say it hits at this point, the y-intercept, and that's at 0, 4. Right? It has a 0x coordinate and then it has a y coordinate. This is your x, this is your y. And then I need another exact random point. So maybe this point right here, which is 3, 3. Okay, and then what I'm going to do is label this x1, y1, x2, y2. And all you got to do is put it in the formula. So formula is y2 minus y1, x2. So go ahead and write this on your notes because you might need it. X2 minus x1. Okay, so this is why I labeled these points so I don't get confused. So my y2 is 3 minus my y1 is 4. My x2 is 3 minus my x1 is 0. Okay, so 3 minus 4 is negative 1. 3 minus 0 is 3. So it looks like my slope is negative 1/3. That kind of makes sense. So if you start from here and you rise 1 and then we run 3 to the left, you get to this exact point on the graph. So that looks good. So yeah, definitely negative 1/3. Okay, let's move on to the next one. So this graph is going to the right, so it's definitely positive. So what I'm going to do is pick two random points. So it looks like it hits at this point, which is could be expressed as negative 2, 0. And then it looks like it also hits it. right here. You could pick here, or you could pick this one or this one. It doesn't matter as long as it's an exact point. So if I choose this point right here, that would be expressed as 0, comma, positive 2, right? Because we always go on the x and then on the y, right? Okay, so this is x1, y1, x2, y2. So my slope is going to be y2, which is 2, minus my y1, which is 0. My x2 is 0, minus my x1 is uh negative 2. So be careful. It's if you call slope is y2 minus y1, x2 minus x1. So my x2 is 0 minus a minus 2. So on the top, 2 minus 0 is 2. And then on the bottom, 2 negatives becomes a positive, so that's 2. 2 divided by 2 is 1. Okay, that makes sense. 1, or you could think of it as 1 over 1. Because if you start at this point, how much do you rise? 1 and then run 1. Good. Okay, so this time they don't give us a graph, they give us coordinates. So that's okay. So what you do is when you have two coordinates, label them. This is x1, this is y1, this is x2, this is y2, right? So slope is y2 minus y1 over x2 minus x1, right? So my y2 is 6 minus my y1 is 3. My x2 is 5 minus my x1 is negative 1. So minus and minus 1. So 6 minus 3 is 3. And then over here, 2 negatives becomes a positive, so that's 6. So if you reduce this, this could be reduced, right? Because you want it in the most simplified. So they looks like they both can be reduced by 3. So this is going to be 1 over 6 divided by 3 is 2. Okay, so my slope is 1/2. Okay, so this one, same idea. They give you two coordinates. They want you to find the slope, so I'm going to label this x1, y1, and then x2, y2. So slope is y2, which is negative 7, minus y1, which is 2. X2 is 0, minus x1, minus 3. So on the top, what is negative 7 minus 2? Negative 9. And then on the bottom, 2 negatives becomes a positive, so that's 3. What is negative 9 over 3? Negative 3. So the last one. Okay. Submit. Okay, so good. Okay, let's talk about y-intercepts in linear functions. So what is the y-intercept in a linear function? So it's always on the y-axis. So here's your x. So like this is your x-axis, this is your y-axis. Your y-intercept will either be somewhere anywhere on this vertical line, right? So as it looks like it's at 2, right? It can also be in negative, that's fine. But as long as it's anywhere touching this vertical line, you have a y-intercept. Okay. So identify the y-intercept. So this one, it's good that if they give you a graph and you want to find the y-intercept, locate where it touches the y-axis, it touches is at 2. So you can say you can rewrite this as a coordinate. It can also be expressed as 0, comma 2, or I don't know if they just want 2. Let's see. Yeah, so they want it as a y coordinate. So in a y-intercept, so there's a few you can knock out. In a y-intercept, the x coordinate will always be a 0, and then the y coordinate will always be a number. Okay? So Yeah, that's how you know that's a big clue. You know you have a y-intercept when the x coordinate is 0 and then the y coordinate is a number. So it's 0, it is 0, comma 2. It's not this one because your x will always have to be 0. This is more of an x-intercept. The same here. This is also 2, comma 0 is an x-intercept. This is a y-intercept, but it's the wrong one. Ours touches on the y-axis at positive 2. Identify the y-intercept. So this one, pretty simple. It looks like our y-intercept is at negative 3. So it would be, as a coordinate, it would be 0, comma negative 3, right? The x is always going to be 0, and the y will always be a number. Okay, this one. What is my y-intercept? It looks like it hits it on the y-axis. It goes through the origin 0, 0. So this one right here. Yep, pretty fun, right? Yes, it is. Okay, so this time they don't give you a graph and they still want you to find the y-intercept. So there's several ways you could find the y-intercept if they just give you a graph. Um, so if it's in the form of y equals mx plus b, did you know that the y-intercept is always b value or the one without the letter? So it's the constant. So in our case, our b is 5. I mean, our y-intercept is 5. So my b is 5. That means my y-intercept is 5. And if you look at all the choices, it's in a coordinate. So how would I express 5 as a coordinate? 0, comma 5. Now, sometimes they might put it in a standard form. And then the other way to finding a y-intercept is sometimes they won't put it in this form, in this format. And sometimes they'll put it like in x-intercept, so like 2x plus 4y equals 20, something like that. So how would you find the y-intercept? You could solve for y, right? And just get y by itself, or you can do this. You can to find the y-intercept for any graph, you can plug in 0 into x and solve for y. Right? That's it. So this case, because it's in the form of y equals mx plus b, my b is 5. Or my y-intercept is 5. So it's 0, comma 5, this one. Okay, this one, find the y-intercept. So this one is still in the y equals mx plus b form. My b is negative 2. So my b is negative 2. So my y-intercept is 0, comma negative 2. This one. This one, identify the y-intercept from the equation y equals negative 2x. Um, this one, it is in the form of y equals mx plus b. Here, let me clear. This is in the form of y equals mx plus b, but what don't you see? There's no constant. There's just a negative 2x, right? There's no plus b, right? There's no plus 7 or so what that means if you have no number, your b is automatically 0. So our case, our y-intercept is 0, 0, meaning it goes through the origin. Okay. Okay, slope and intercept. So we kind of talked about both before. A slope is a rise over run. The y you have two intercepts. You have also an x-intercept. Here, let me clear. So let's pretend this is your linear line. Um, Here's your x-axis and here's your y-axis. So believe it or not, you have two intercepts. You have a y-intercept here, and then you have an x-intercept. So this is your y-axis, and then you have an x-intercept here. So anywhere where it touches the x-axis, you have an x-intercept. Anywhere on the y-intercept, that's your on the y-axis, that's your y-intercept. Question one, find the slope and the y-intercept of the following function. So this is a linear line. It's just a little bit off. It's in standard form, right? So yeah, if you need a refresher on linear lines or graphing linear lines, go ahead and check out my supplementary videos on linear functions. It'll explain from scratch how to graph a linear line, what kind of forms there is. But this is a linear line and it's in the form of it's in standard form. AX plus BY equals C, right? What we want to do is put it in slope intercept form, right? We want it in slope intercept form. This form, y equals mx plus b. Because if we put it in this form, you can find the slope. The slope is the m, basically the number in front of x, and then your b is your the constant, right? So that's what we're gonna do. We're gonna get y by itself. So first, to get y by itself, I'm gonna subtract 6x, and you get negative 3y equals negative 6x plus 9. And then you're going to solve for y, so you're going to get rid of this negative 3 by dividing everything by negative 3. Okay. Negative 6 divided by negative 3 is positive 2x. 9 divided by negative 3 is negative 3. So my slope is the number, if you have it in this form, the slope is always the number in front of the x. So my slope is 2. And then my b is negative 3, or the y-intercept. B is the same thing as your y-intercept. So my y-intercept is negative 3. So slope is positive 2, and y-intercept is negative 3. Looks like the second choice, right? Positive 2, m is positive 2, and y-intercept is negative 3. Good, good job. Let's look at question 2. Find the slope and the y-intercept. So let's put it in not standard for what y equals mx plus b. So we got to get y by itself. So your y is on the right side. So first I would do is add 16 to both sides. So you get, so this cancels. So you're left with 17y equals to 8x plus 16. Then what you want to do is to solve for y, you're going to divide both sides by 17. So you get y equals 8 over 17, that's 8 over 17x. 16 over 17 is like 16 over 17. I don't think you can reduce. Okay, so my slope is going to be 8 over 17, and my b, or my y-intercept, is this value. 16 over 17. So which one is that? Slope is 8 over 17, and the y-intercept is 16 over 17. This one. Right? Not too bad, right? Okay, let's do this one. Find the slope and the y-intercept of the following function. It looks way off, but what you want to do is just put it in the form of y equals mx plus b. Get y by itself. The slope is the number in front of m. I mean, the in front of x, and your y-intercept is your constant, your b. So what would I do here? So we have, on the left, we have 8y minus 4x plus 9 equals to 41. So what I would do first is move this 9 to the right by subtracting 9 from both sides. So you get 8y minus 4x equals to, what's 41 minus 9? Oh, without a calculator, it would be 10, 11. It would be 232. Okay. And then continue solving for y. So the next thing I would do is move this negative 4x to the right by adding 4x, right? So this cancels. So you're left with 8y equals to 4x plus 32. Then what I would do is get y by itself by dividing both sides by 8. And you get 4/8, which can be reduced by 4, which is 1 over 2, right? And then 32 divided by 8 comes out nicely as 4. Okay, so my slope is 1/2 or 0.5, and my b is 4. Letter B, right? Slope is 0.5, and my b is y-intercept is 4. Correct. Okay, two more. Let's do this one. Question 4 says find the slope of the y-intercept. Okay, so it's a little bit more difficult, but the same idea. Just get y by itself, right? Put it in the form of y equals mx plus b. Your slope is the number in front of the x, and your b, your y-intercept, is the constant. So let's see, locate where the y is. The y is right here, so let's get everything else to the left. So wait, first off, remember when we're doing one and two steps equation, always check if you can combine like terms on the left side and on the right. So on the right, we have a y, we have an x, and a constant. Constant, they don't mix. Left, variable and a constant, yeah, they don't mix. So let's go ahead and move this negative 5x to the left by adding 5x. And then let's get rid of this 19 by subtracting 19. Okay, so this cancels, this cancels. So you're left with 7y. You could put this on the right or left. It doesn't matter because of the commutative property. I'm just going to put it on the left because I like y on the left. That's it. And then what's 9x plus 5x? 10, 11, 12, 13, 14x. And then what's negative 16 and negative 19? Negative 35. Okay. So go ahead and solve for y. So you're going to divide everything by 7. Okay, so what's 14 over 7? That's 2x. What's negative 35 over 7? Negative 5? Yes, negative 5. So my slope is a number in front of x, so my slope is 2, and my b, or my y-intercept, is negative 5. Yeah, first one. Okay, last one. I think that's it for this section, and then we'll move on. So this one, we got to find the slope and the y-intercept, so we have to get y by itself. So over here, this is your left side. Over here, this is your right. So remember, the first step is make sure before you move things around, always check if you can combine like terms. So on the right, we have y, x, and constant don't mix. Left, we have an X and a Y. Oh, X, Y, and so we have two Y's, so but they don't mix. So what I would do first, the first step I would do is get all the Y's on one side. So let's move this 3Y to the left. You could also move the 5Y to the right. It doesn't matter. I mean, it's just a little bit, it's just one more step to do if you do that. Okay, so this cancels. So you're left with 11x. And then 5y minus 3y is 2y. And then minus 13. Over here we have negative 6x plus 18. Okay, then what I'm going to do is start getting y by itself. So maybe let's move this negative 13 to the right by adding 13. Move this 11x to the left by subtracting 11x. This cancels, so you're left with 2y equals, what's negative 11 and negative 6x? Negative 17x. What's 18 and 13? 9, 10, 11, carry the 1, 1, 2, 3. Last step, solve for y by dividing both sides by 2. And y equals negative 17 half x plus 31 over 2. Okay, so it looks like my slope is negative 17 over 2. Let's, if you look at our choices, it's improper, so let's make it mix. So what's negative 17 over 2? How many times does 2 go into 17? About 8, because 8 times 2 is 16. 17 minus 16 is 1. So it's going to be, this is the same thing as 8 and 1/2. And then my y-intercept, this is improper, so let's make that mixed. So put 31 in the box and 2. How many times does 2 go into 31? Well, I know that 2 go into 3 once. 3 minus 2 is 1. Bring down the 1. How many times does 2 go into 11? About 5. And then you have a remainder of 1, so it's going to be 15, and your remainder is 1 divided by 2, so 15 and 1/2. Yep, this one. Correct. Okay, we're gonna stop here. So later on when we do the practice, so you have a good found you kind of have a little introduction of linear graph. So in one of the word problems on the practice exam, I noticed that you're gonna have to learn how to graph a linear function. So maybe that's the next thing we'll have to learn. Okay, I'm gonna stop here.